Hi, today I'm going to talk about the ADA checklist. The building I chose to do was the Deike building, which is located on Penn State University's main campus. My name is Julianna Mastrorilli, and this is the final project for RHS 100. So the purpose of the ADA checklist is to make sure that existing facilities are more usable for people with disabilities. The checklist helps to identify accessibility problems that the building may have under the obligations in the Americans with Disability Act. The improvements that are suggested in this video will help to remove barriers that are currently in place in the building, and the process of determining what barriers are readily removable is not a one-time effort. The barriers need to be reevaluated every year in order for the building to be at its peak. So the building I chose to do is the Deike building. Yet again, it's located on Penn State's main campus. It was built in 1964, and it was originally the Mineral Industries building, but it was renamed shortly after it was built after renowned alumni George Deike Sr. and George Deike Jr. and their family. And it is currently home to the College of Earth and Mineral Sciences. So this is just the map of the main entrance into Deike, which is located in here. And then Hostler is attached to the other side of it too. So this is the main entrance in. I just wanted to put that up. And then these are the floor plans for the 6 floors that are in Deike. So the ADA checklist has 4 main priorities, and these priorities are recommended based on Title III regulations for planning readily achievable barrier removal projects. The first being the accessible approach and entrance, which this is from the time that the person arrives on site of the building. Can they get from, they have an accessible parking spot, an accessible route of travel into the building, and is the entrance itself accessible. The second being access to goods and services. So since this is a building on campus, are the classrooms, the teachers' offices, the museum that is located in there, the dean's office for the College of Earth and Mineral Sciences, are these all accessible to people of all abilities? The third priority being access to restrooms. So basically, can people of all abilities get into, or do they have at least one bathroom? And finally, any other measures necessary, which in this case is mostly just drinking fountains and telephones. So on to priority 1. People with disabilities should be able to arrive on site, approach the building, and enter as freely as everyone else. At least one route of travel should be safe and accessible for everyone, including those with disabilities. So the first subcategory we have is route of travel. So yet again, this is just from the time that the person arrives on the site. Are they able to get from their parking spot, or just in general from where they are into the building? So is there a route of travel that does not require the use of stairs? And yes, there's 3 entrances to the building, and all 3 of them are on the ground level. 2 of them do not require the use of stairs at all, and 1 of them does, but that entrance also has a ramp down the side of it, so all 3 entrances are accessible. Is the route of travel stable, firm, and slip resistant? Yet again, all 3 are, 2 of them are ground level, 1 of them has a ramp. So they're made of concrete, and they have the little divots in the edge, as you can see in the middle picture over there. So they are. Is the route of travel at least 36 inches wide? For the entrance that I measured closest to parking, it was 36 inches wide. 72 inches wide. So for the route of travel that was measured closest to the parking, it was 72 inches wide. And can all objects protruding into the circulatory paths be detected by a person with a visual disability using a cane? The entrance that was measured had no objects protruding into it. And do drop-off curbs have curb cuts at drives, parkings, and drop-offs? And you can see in the middle one over there that they do. And then there were no barriers for this section. These are just a list of possible solutions that could be used if there were barriers in the route of travel. Up next, we have ramps. So this building really only had one ramp. It's more, as you can see in this bottom picture right here, it's more of an inclined slope, but technically it can be considered a ramp. So the slope of the ramp is 6 feet 2 inches to 96 feet 4 inches, which comes out to a ratio of 0.064. And 1 to 12 is 0.083. So yes, the slope of the ramp is no greater than 1 to 12. And then this ramp is longer than 6 feet, and it does not have railings on both sides. Yet again, it's not a true ramp, but it probably should have railings on it at some point. So no, it does not pass this one. This is a barrier. Yet again, there are no railings. The width between the curb is 44 inches, so this passes. The ramps are slip resistant, they're concrete, and at the beginning it has divots. And then, is there a 5 foot long landing every 30 foot horizontal length of the ramp at the top and bottom of the ramps and at the switchbacks? So there are no landings or switchbacks, so that one is a barrier as well. And does the ramp not rise more than 30 inches between landings? Yet again, it rises 6 feet 2 inches, so that's a barrier as well. So some possible solutions to solve these barriers include relocating the ramp. If available space is limited, reconfigure the ramp so that it can include switchbacks, add railings, and remodel or relocate the ramp. So these solutions are just possible solutions that could be done to the building. If this is a barrier that we decide to move forward with, these are the solutions that we would want to try and use in order to remove this barrier from the building. Up next, we have parking and drop-off areas. And this is just, for the parking, are there enough spots for the people with disabilities? Is there enough accessible parking and accessible aisles? And does it connect to the accessible route of travel? So, are there an adequate number of accessible parking spots available? And no, there were not. There are over 52 cars in this parking lot, and there's only one accessible parking spot. For a parking lot of that size, there should be 3 accessible parking spots with their accessible aisles. So no, that's a barrier. Are 8 foot wide spaces with a minimum 8 foot wide access aisles and 98 inches of vertical clearance available for lift equipped vans? There is that the one accessible spot is a van accessible. Does have an 8 foot wide space. The width is 8 feet and the vertical clearance is over 98. As you can see in this picture, there's nothing above it, so there's no problem there. Is the accessible aisle part of the accessible route of entrance? And yes, the aisle connects directly to the curb that was seen in the route of travel picture. Are the accessible spaces closest to the accessible entrance? All 3 entrances are accessible. The entrance that the parking is located closest to is not the main entrance. It's across from the main entrance on the other side of the building, but it is still an accessible entrance. And are the accessible spaces marked with the international symbol for accessibility? And are there signs reading van accessible at the spaces? And in this picture, you can vaguely see that it says accessible parking and then underneath van accessible space. And then yes, there is an enforcement procedure on campus to make sure that the accessible parking is used by people who actually need it. It is through the university police. So some barriers that could be removed here by these possible solutions. The first being to reconfigure a reasonable number of spaces So there's not the one barrier in this is there's not enough accessible parking spaces, but there are 52 parking spaces in the parking lot. So currently there's one parking spot, one accessible parking spot, one access aisle, and 51 other spots. If one of the other parking spots was turned into another van accessible spot by repainting stripes or reconfiguring the spaces, then they would be able to, then the barrier would be able to be removed here. So up next we have the entrance. So just before we start, this is the entrance on the top over here of the main entrance, which is the one with the ramp, and the bottom one is the entrance closest to the parking. They're both accessible. So if there are stairs at the main entrance, is there also a ramp, or is there an alternative accessible entrance? Both are true, so that passes. Do all inaccessible entrances have signs indicating the location of the nearest accessible entrance? And all the entrances are accessible, so that is not necessary. Can the alternative accessible entrance be used independently? And yes, all three accessible entrances can be used independently. 2 of them are on the ground level, and the third has a ramp. Does the door have at least 32 inches of clear opening? And for a double door, at least 1. And the clear opening was measured to be 36 inches. Is there at least 18 inches of clear wall space on the pull side of the door next to the handle? And this was measured to be 22 inches. And continuing, before we start, okay. Is there a threshold of at least 1/4 inch high or less, or if it's a bevel edge, is it less than 3/4 of an inch? And the threshold was measured to be 1/4 of an inch high. If provided, are the carpeting or mats a maximum of 1/2 inch high, and they were measured to be 1/4 of an inch high? Are the edges securely installed to minimize tripping hazards? And as you can see over here, the mat is easily kicked up. So if someone kicks that up, it could be a tripping hazard to someone else. Okay. Is the door handle no higher than 48 inches and operable with a closed fist? The height is 44 inches, and you can easily put your hand in and turn it and pull it out. Can the door be opened without too much force? And the door is automatic, so yes. And finally, if the door has a closer, does it take at least 3 seconds to close? It was measured to take 5 seconds. So the only barrier for this was the mats. They were easily, they were not secured along the edges. So the one possible solution for this that we can use is secure carpeting or mats along the edges. And this would just reduce tripping hazards for anyone who couldn't see the mats or just isn't paying attention. So on to priority 2, which is access of goods and services. So ideally the layout of the building should allow for people with disabilities to obtain materials or services without assistance. So in this building, there are classrooms, lecture halls, there's a museum, the dean's office for the College of Earth and Mineral Sciences, and many professors' offices. And basically, this category or priority is just ensuring that people of all abilities are able to go to all of these places. So the first subcategory is horizontal circulation, and the first question is, do the accessible entrances provide direct access to the main floor, lobby, or elevator? So the 3 accessible entrances all come into the main floor. They also, one side of the building has 2 accessible entrances, and there are 2 elevators located on that side. And the 3rd accessible entrance is located on the opposite end of the building. And the 3rd elevator is located over there, which all 3 elevators provide access to all floors of the building. Are all public spaces on an accessible route of travel? Yes. The elevators the elevators provide access to all accessible all public spaces except for this one lecture hall up here, which you can see there's stairs right there, but this mini elevator was installed in order to allow access into that building, into that lecture hall. Is the accessible route of travel to all public spaces at least 36 inches wide? It was measured to be 96 inches. And is there a 5-foot circle, a T-shaped space for a person using a wheelchair to reverse direction? And there's a space of 144 by 144 inches in the main lobby. And there are no barriers. Onto doors. So are the doors do they have at least a 32-inch clear opening? It was measured to be 36 inches wide. On the pull side of the doors, is there at least 18 inches of clear wall space next to the handles? And there was 18 inches. Can the doors be opened without too much force? The doors are automatic. And are the handles 48 inches high or less and operable with a closed fist? And they're 46 inches high, and yet again, they're operable with a closed fist. And are the thresholds a fourth of inches high or less? And yes, they are. A fourth of it. And there are no barriers, so there's no solutions. And then on to rooms and spaces. So are the aisles and pathways to materials and services at least 36 inches wide? And as you can see in this picture up top, between the back aisle and the wall, it's only 34 inches, so that's a barrier. Is there a 5-foot T-shape? It's 62 by 144 inches, which you can make a T-shape from. So the carpet is low pile, tightly woven, and securely attached along the floors, as you can see in all 3 pictures, really. And then are all objects cane detectable? And the only thing that really sticks out are these cabinets in the back that go from 0, so they start at the ground and go to 44 inches high. They protrude 2 inches from the floor. And then, so to remove the barrier of the aisles not being long enough, the possible solution is to rearrange the furnishings and fixtures. As you can see back in this picture, the chairs could be, the organization of the room can just be reconfigured in order to allow the aisles to be, or between the back wall and the first row to be. Next is emergency egress. So this just wants to know if emergency systems are provided, are there both flashing lights and audible signals? And yes, for the fire alarms, they provide both, and the defibrillator provides an alarm, and then the device itself lights up when it's in use. So there's no barriers. So signage for goods and services. If the signs are provided designating room numbers, permanent rooms and spaces where goods and services are provided, do they comply with the appropriate requirements for such signage? And yes, it basically means, does it fit the rest of these? Which, is it mounted with centerline 60 inches from the floor? Yes, it's mounted 60 inches. Is it mounted closest on the wall adjacent to the latch side of the door as close as possible? Yes. There's a better picture on the next slide. Raised characters are 1 1/4 inches. There's braille text with the same information provided. And if a pictogram is used, it must be accompanied by raised characters and braille, which is seen better on the bathroom signs, but you can kind of see it on this slide. And there's no barriers. So up next, directional and informational signage. If mounted above 80 inches, so they have letters at least 30 inches high with high contrast and non-glare finish. And the highest letter height was the exit sign, which is 96 inches off the ground. And do they comply with legibility requirements for the building, which just is from the previous slide, and yes. Again, there's no barriers. So onto controls, which this just includes any mechanical, electrical, gaming services, controls. And in this picture, there's the light switches for the room and the dimmers, and then the thermostat. And this was just in one of the classrooms. Are all the controls available for use by the public, located at accessible height? And yes. The reach range, these just show the requirements for the different, like if it's a side reach, front reach. And the one that I measured is the light switches over here, which are 46 inches at a forward reach. And that one we'll just do as an example too, is the thermostat, which is accessible at a side reach, and so the max for that is 54 inches, and as you can see it's 50 inches, so that one would pass as well. Are they operable with a closed fist? Yes, they all are. As you can easily see, you could easily dim the lights or work the thermostat with a closed fist. So there's no barriers. And finally on to seats, tables, and counters. So this is just asking, are the aisles between fixed seating at least 36 inches wide, and they're 40 inches between them, so that passes. There are not spaces for wheelchair seating that are designated to be distributed throughout. There easily could be, but the room does not have any designated to be. Are the tops of tables or counters between 28 and 40 inches high? And they are 29 inches. Is there knee spaces at the table at least 27 by 30 by 19 inches? And the height with depth is 29 by 60 by 30 inches, which the tables are technically meant to be for 2 people, but this would still pass as 30 times 2. You can just say they each get 30 inches wide. At each type of cashier counter, is there a portion of the main counter that is no more than 36 inches high, which we can just say in this case is the teacher's desk or the professor's desk. No more than that. And there's no type of counter, but the professor's desk was yet again 29 inches high. And then there are no food ordering counters, so this one doesn't really apply to the room. There are no real barriers, so that one can be skipped. And then finally, onto vertical circulation. Are there ramps, lifts, or elevators to all public levels? Yet again, this is really the only exception to the 3 main elevators that access at all the other buildings, and then this elevator accesses this one lecture room located up here. On each level, if there are stairs, yet again, this is the alternative accessible route that is allowed. And then there's 3 elevators to all floors, so there's 3 accessible routes to every floor in the building. Again, no barriers. Onto stairs. Do they have non-slip surfaces, which as you can see here, these are made to be non-slip. They have little treads in them. And do all stairs have continuous rails on both sides with at the bottom and top? And as you can see, the railings wrap around in both these pictures, and they do extend above the top and bottom. There are no barriers for this section. And onto elevators. Are there both visible and verbal or audible door opening and closing and floor indicators? 1 tone up, 2 tone down, and yes, when you ride the elevator, if you're going up, it makes 1 tone. If you're going down, it makes 2 tones. Are the call buttons in the hallway no higher than 42 inches? They are located exactly 42 inches off the ground. Do the controls inside the cab have raised and braille lettering? They do. You can see in this picture and on the next slide for lifts as well. Is there a sign on both door jabs at every floor, identifying the floor as raised and braille lettering. And over here you can see these are both of them for ground, and there are them at all the floors, ground through the 5th floor. If an emergency intercom is provided, is it usable without voice communication? And yes, there is one provided, and there's a call button, and you can use it without voice communication. The picture is on the next slide. Is the emergency intercom identified by braille and raised lettering? Yes, the picture is on the next slide. We'll go into that. There are no barriers here, so we can skip this. As you can see here, just real quick, this is the emergency intercom, and there's braille lettering underneath to identify it. Can the lift be used without assistance? If not, is there a call button provided? And there's both braille and numbers and everything on here, so it can be used without assistance, and there is a call button provided as well, though. Is there at least a clear space of 30 by 48 inches, and the clear space was measured to be 81 by 48 inches? Are the controls between 15 and 48 inches high? And they're between 30 and 44 inches. So yet again, there's no barriers for the lifts. And now we're on to priority 3, which is usability of the restrooms. So getting to the restrooms. If the restrooms are available to the public, is at least one restroom fully accessible. And yes, there are 2 accessible restrooms, one for each gender. And there are actually not signs at inaccessible restrooms that give directions to accessible ones, though. You can see in this picture, it doesn't say anywhere, and they're at the men's one as well. So just to solve that barrier, is the easy solution is to install accessible signs at the inaccessible restrooms to give directions to the accessible ones. Doorways and passages. Is there tactile signage identifying restrooms? And yes, there are signs on the wall at every restroom. And yet again, you can see the pictogram used. So the door at least 32 inches clear is measured to be 34. Can the doors be easily open? The accessible bathrooms have automatic doors, so they're easily open. Does the entry configuration provide adequate maneuvering space for a person using a wheelchair? And the clear width of the entry configuration is only 31 inches, so it does not. And yet again, there's not a 31. This is 31 inches. There's not a 36-inch wide path to all fixtures. So some possible solutions to solve this barrier include removing the obstructions or removing the partitions. And this would just allow for there to be a 36-inch wide path to all the fixtures in the bathroom. Stalls. So is it operable with a closed fist, inside and out? And yes, it's just one of the movable latch doors. Is the stall have an area that is accessible, and it's 59 by 64 inches, which isn't 5 feet by 5 feet, but it's more accessible than a typical stall provides. And as you can see in this picture, there's grab bars both behind and on the wall closest to the toilet. And then the toilet seat is 18 inches off the ground. So no barriers. And then onto lavatories. And the clear space in front of the lavatories, there's 2 of them, is 62 by 60 inches. And then the rim is 32 inches high. There's 30 inches from the bottom of the floor to the lavatory apron. And then one of those faucets is automatic. The other one is just easily operable with a closed fist. So you can lift it up and move it back and forth for hot and cold. Are the soap and hand dryers within reach ranges and usable with one closed fist? They're both within reach ranges, and the soap is just a pump, and the there's no hand dryers, it's paper towel, and you can just easily pull it off the wall. It is a mirror mounted with the bottom edge of the reflecting surface 40 inches high or lower, and it is mounted at 40 inches high. So there are no barriers. And on to priority 4, which is additional access. When amenities such as drinking fountains and telephones are provided, they should be accessible to people with disabilities. This priority is for items that are not required in the first 3 priorities. So the first subcategory is drinking fountains. And is there at least one fountain with a clear floor space of 30 by 48 inches in front? And yes, the one that is closest to one of the accessible entrances is 49 by 100 inches. Is the spout no higher than 36 inches from the ground? The spout starts at 36 inches from the ground and the water comes out at 38 inches, but it's talking about where the spout starts, so yes. Are the controls mounted on the front or on the side near the front edge and operable with a closed fist? They're mounted on the front and on the side, as you can see there, closed fists in that picture operating it. And are they cane detectable, located within 27 inches of the floor or protruding into the circulation space less than 4 inches from the wall? As you can see here, there's an empty space underneath it. So it protrudes only 7 inches from the wall in the back, but then there's a 29-inch space from the ground to where the bottom of the water fountain is, so it's technically not cane detectable. And a possible solution to this is just to place a planter or other cane detectable barrier on each side at floor level to make this water fountain cane detectable. And many of the other water fountains throughout the building are like this as well, so that would have to be done to all of them. Then on to telephones. So there are telephones for use in the public spaces. And is there a clear space of at least 30 by 48 inches in front? And there's a space of 40 by 120 inches in front of this telephone in one of the classrooms. Is the highest operable part of the phone no higher than 48 inches, and it's 37 inches from the ground when it's put in its holder, and then there's the chain on it so it can be moved up and down as well in height. Does it protrude no more than 4 inches into the space? It protrudes 3 inches. Does the phone have push button controls? As you can see in the bottom picture over here, it does have push button controls. Oops. Is the phone hearing aid compatible? And yes, it is. Then on to the next slide. Is the phone adapted with volume control? The bottom right button over there says high volume, so there is volume control. Is the phone with volume control identified with the appropriate signage? It does not say that, so no. If there are 4 or more public phones in the building, is one of the phones equipped with a text telephone? There are more than 4 and there is not. And is the location of the text telephone identified by accessible signage bearing the international TDD symbol? And there is not. So some possible solutions to these barriers include having a portable text telephone available, adding signage for the text telephone, or installing the text telephone. So either having a portable TT available or having a text telephone somewhere and having the signage for whichever option is chosen. It is not enough to simply complete the checklist. The barriers that are identified in this building need to be considered before improvements are made. So the most significant barriers need to be considered, and there needs to be identified what can be done to improve or fix them. So the improvements made ideally will greatly improve the building's accessibility. yet again, the checklist is not a one and done type of deal. It is something that needs to be reevaluated annually in order to keep identifying the most significant barriers and the most important improvements that need to be made to the building. So this is just a summary of priority 1. The route of travel had no barriers. The ramps, there were no railings, switchbacks, or landing at that one ramp. That's not the main entrance. So my recommendation for improvement would be to remodel the ramp, add railings, and remodel it to include switchbacks. And then the dropping park-off area, the barrier was there are not enough accessible parking spots for the amount of parking spots in the total parking spot area. So a possible solution would be to reconfigure a reasonable number of spaces by repainting stripes, reconfiguring to provide the inaccessible spaces, and reconfiguring the existing spaces. So basically right now there's 52 spots, or 53 total spots in the parking lot. Only one is an accessible spot, and it's also a van accessible spot. But for a parking lot of that size, there should be 3 accessible spots, so any of these could be done to reconfigure it so that there are 3. And then finally, the entrance, the mats were not securely installed, which is a tripping hazard. So a possible solution, and my recommendation for improvement, is to just secure the mats at the edges to reduce the tripping hazard. On to priority 2. So there were no barriers for horizontal circulation, emergency egress, signs to goods and services, directional and informational signage, controls, vertical circulation, stairs, elevators, and lifts. The barriers for the doors included that there was only 16 inches of clear wall space on the pull side of the door, and the possible solution here is to reverse the door swing or remove obstructions. And then for seats and barriers, there are not enough spaces for wheelchair seating distributed throughout. And there is not at least 36 inches between fixed seating. There was only 34? Yeah, there were only 34 inches. So a possible solution to fix this and would be just to rearrange the tables to allow for wheelchair seating in areas throughout the and for seating areas throughout the area, and allow for there to be at least 36 inches between fixed seating. Yet again, the furniture in the room can easily be reconfigured so that the aisle between the back wall and the back row of seating is more than 31 inches. On to priority 3, getting to the restrooms. There are no signs at inaccessible restrooms that give directions to accessible ones. So possible solutions include installing signs at the inaccessible restrooms that give directions to the accessible ones. Doors and passages. So the entry configuration does not provide adequate maneuvering space for someone using a wheelchair, and there is not a 36-inch wide path to all fixtures. The path is only 31 inches in the entry configuration, so the possible solution would just be to remove obstructions, which is the wall between the door and lavatories, and to widen the entry configuration so that there is a 36-inch wide passage to all fixtures, and the maneuvering space is adequate for someone using a wheelchair. And then there were no barriers for the stalls or the lavatories. Finally, on to priority 4 for drinking fountains. Some of the drinking fountains are not cane detectable, and the improvement would just be to place a planter or other cane detectable barrier on each side of the fountain at floor level so that the drinking fountains are cane detectable. Onto telephones. There are no text telephones provided in the building or signage for them. So a possible solution would just either for there to be a portable text telephone in the building, or for there to be one of the telephones in one of the classrooms to be a text telephone and have signage to whichever one is chosen. And then finally, onto the pros and cons of the building. The first pro being all routes of travel and entrances into the building are accessible. So whichever way someone wants to enter the building, they can. People of all abilities can get into all the entrances, through all the entrances. And they are also stable, meaning they're slip resistant, they're made of concrete, there's curb cuts. They're all easily able to be operated. All doors and stalls can be operated with a closed fist and without too much force. So all doors into the building and into the accessible bathrooms are automatic, so they do not require a lot of force. And doors that are not are easily operated with a closed fist. Threshold edges are either met or under the requirements for entrances and doorways throughout the entire building. The building has adequate horizontal and vertical circulation. Yet again, there's 3 elevators to all floors of the building, and the one classroom that is not accessed by these 3 elevators has its own elevator, which is the alternative route since there's stairs. All goods and services are accessible from the accessible entrances and have the appropriate signage. As before, there's the 3 elevators and the 4th elevator to the one classroom, and they all have appropriate signage. The controls are all located in accessible areas and at accessible heights. Emergency systems have both flashing lights and audible signals. All restrooms have accessible stalls and lavatories. All drinking fountains and telephones are located at accessible areas and accessible heights. And finally, doors, stalls, lavatories, and water fountains are all operable with a closed fist. And now onto the cons of the building. First being there's not enough accessible parking spots or van parking spots. The mats are not securely installed at the edges. The main entrance ramp, which is more of an incline slope, as we said before, does not have railings, level landings, and rises more than 30 inches between the landing. There is no landings either, so there are no directions to accessible bathrooms from the inaccessible ones. Then the entry configuration in the bathrooms is only 31 inches, so there's not a 36-inch wide path to all fixtures. The drinking fountains are not cane detectable. They're mostly uniform throughout the entire building, so all of them are not just the one that was measured. And finally, there are no text telephones or signage for the appropriate ones. So this concludes my evaluation of the Deike building following the ADA checklist. As you can see, there are more pros than cons for this building. Overall, the Deike building has pretty good accessibility, but obviously there are improvements that can still be made. As seen in the previous 4 slides, the barriers are easily identifiable, and the improvements that need to be made were identified throughout. Thank you!